In this problem, we're looking at a perfectly elastic collision in one dimension. So we have a rather heavy cart at 1/2 of a kilogram, and it starts from rest, and we shoot a small rubber ball at it at a pretty high speed of 40 meters per second. And the ball has a mass of 0.15 kilograms. And the ball is going to bounce off of the cart and actually reverse direction. If you have some experience with elastic collisions, a light thing hitting a heavy thing always causes the light thing to be reflected. Provided the heavy thing starts from rest. So I've drawn it that way with my final velocity on the ball going to the left. But if you don't know for sure that final velocity is going to be negative, you can just throw it into your calculations as a positive v1 final. And if v1 final comes out negative in the end, you know it's actually going to the left. So that's the approach I'm going to take in the mathematics here. And there's two things that we have to enforce in an elastic collision. First, the initial momentum has to be equal to the final. And my initial momentum here is just a 0.15 kilogram mass multiplied by 40 meters per second. My final momentum has two different terms, one for each moving piece. So that's going to be my little mass of 0.15 times v1 final. Again, I just put that in as a positive v1 final, but if it comes out that v1 final is negative, I know it goes to the left. And then the momentum of the cart itself, which is 0.5 times v2 final. So this gives us the first equation in a system of equations. So I'm going to clean this equation up by multiplying by 20 on both sides. And the reason I'm choosing 20 is because I notice if I multiply by 10, that would clear the decimal out of the last term, but it would give me a 1.5 on the first term on the right. So if I multiply by an additional factor of 2, in other words by 20, it's going to clear all the decimals in the smallest possible way. So this cleans up to 120 is equal to 3v1 final plus 10 v2 final. The second condition that I need to enforce with an elastic collision is that the total kinetic energy in the initial state is equal to the kinetic energy in the final state. In the initial state, there's only one thing moving, so I take 1/2 times the mass times the speed squared. In the final state, two things are moving. The little ball with its final velocity of v1 final, and the cart with its final velocity of v2 final. So to clean this up, I can multiply both sides by 2. That gets rid of all the 1/2s. And I'm really left with all the same decimal coefficients to deal with here. So again, I'm going to multiply by 20 just to clean things up. And this gives me 4,800 on the left-hand side. And that's equal to 3v1 final squared plus 10 v2 final squared. So now we have two equations and two unknowns for my final velocities. But the difficulty here is that I have a nonlinear system of equations because each of those velocities is squared in the second equation. So one way to get this done, of course, would be to plug the system into a computer algebra system and just get your decimal approximations out of that. But I wanted to illustrate an algebra trick to get it done first, and then we'll just check with a computer at the end. And the key to making a clever substitution here is that energy and momentum are conserved before the collision ever occurs. In other words, a valid solution to this is always that v2 final is equal to 0. And that v1 final is equal to v initial, just because that's one way for the momentum and energy to be the same as the initial conditions. All right, so we see this coming. We know that this system is going to produce one valid result in which v2 final is equal to 0. It's not the one we're even interested in, but we know it's going to be a mathematical result. That means if we can do a substitution that expresses this system entirely in terms of v2, it's going to be easy to factor a v2 out of it. So what I'm going to do is take my top equation and solve for v1 final. So when I solve for v1 final in the first equation, I get 120 minus 10 v2 final, all divided by 3. And I'm going to sub that into the second equation in my system. That gives me 3 times 120 minus 10 v2 final, all squared, divided by 3 squared, or 9, plus an additional 10 v2 final squared equals 4,800. I can cancel a factor of 3 here, and I'm going to pull a 10 out of that binomial in the numerator, and when I square that, I get 100. So in the next step, I'm going to do two things at once. I'm going to multiply both sides of the equation by 3 to get rid of this denominator. And I'm also going to expand that squared binomial. So I get 100 times 144 minus 24 V2 final plus V2 final squared plus 30 V2 final squared equals 3 times 4,800. Well, that's 14,400. And here's where the magic happens from recognizing which solution would be easiest to work with. When I distribute the 100 to the 144, that gives me 14,400 on the left-hand side. That cancels the 1 on the right-hand side. When I distribute the 100 in here and combine like terms, then I get negative 2,400 V2 final plus 100 V2 final squared plus another 30. So that's plus 130 V2 final squared is equal to 0. And then, like I knew was going to happen, I can factor out a V2 final. Well, one solution to this is when V2 final is equal to 0, because again, momentum and kinetic energy can be conserved if the collision never occurs. V2 final 0, V1 final is equal to the initial velocity. That's not the one we're interested in. We're interested in the second solution, found by setting that second factor equal to 0. So I add 2,400 on both sides, divide by 130, and I've got my answer for V2 final. And I get 18.5 meters per second for V2 final. Then I'm going to go back to the first equation in my system, because that's the linear one, that's the easy one. And I'm going to solve for V1 final. So I plug in that V2 final, which was 18.5. Solve for V1 final. And I get negative 21.7 meters per second for that. Now, just a quick reminder, when we originally defined V1 final, we did not put a minus sign in that momentum equation. So our default position was to say, well, V1 final points to the right. And when you come out with a minus sign on that, it means it actually points to the left, and this ball was reflected just like I showed in the diagram. One way to check your work here is to now compute the final total momentum and the final total kinetic energy and make sure that they're equal to those initial values of momentum and kinetic energy. But the last thing I want to illustrate in this video is how you would use a computer algebra system to solve the same system of equations. So here we are in WX Maxima. This is a free open source computer algebra system. And I've defined my first equation. I gave it a name, equation 1, and I typed everything in just like it looks in the first linear equation. And then equation 2 is the quadratic one, and typed everything in there. I hit Shift Enter just to get a look at these equations and make sure that I did it right. And everything looks good here. The terms are reversed on the left-hand side, but that's okay. Next, I want to solve the system. So here's what the syntax looks like. And you'll notice that I put the word float out in front of this whole thing. That means I'm going to get a decimal approximation. And then the syntax for solving the system of equations is solve, and then you put the two equations in brackets, the two variables you're interested in brackets. Hit Shift Enter. And I can see the second solution that I'm looking at, V1 final equals 40, V2 final equals 0. That was that extraneous solution that we're not interested in. It's as if the collision never happened. That's one way to conserve momentum and energy. The other one is the one we're interested in. And I can see I missed by a little bit due to some rounding error. V1 final is negative 21.54-ish. I got negative 21.7 the way I rounded. V2 final is 18.46. That rounds to 18.5. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.